Direction. Good morning, morning, morning. Mr. Lesham is here. Bruce, if you don't mind doing the lights again. Thank you, Ollie. Yeah, let's do both. Okay, so what we're doing now, we finish with the identities. If you had any questions about the homework, just let me know after I do this little video and I'll write down the answer on a piece of paper and I'll just post it for you. Just going to be quicker that way. So we're moving on to solving equation, and we've done a lot of that in grade 11. We're going to add something, but maybe not today. Today is more about revision. Okay? So I've got this equation. Okay? Obviously I need to add equals 0, and I want to solve for theta. Okay? Now don't get confused. This is not an identity. We don't need to prove that this is always equal to 0. We just need to find the theta that will work for that. Okay? Does anyone remember how to do that? No. Okay. Right. So what we're going to do is, and we've done easier one. This is a little bit harder one. Here we have to use some identity. So you're right. It is related to the identities. And what we're going to do in this case, every time we'll do something else, we'll move them to the other side. Okay. And then any idea?
So what happens to the negative?
Move that to the other side. Minus, so now it's plus. Yeah, and then what should I do? Yes, okay. Divide by cos and by 2. So what I'm going to get is tan theta equal 3 over 2. Do you understand what I've done here? I divide by cos. Let's do it in 2 steps. Okay. So sine theta over cos theta divided by cos and divide by 2. So 3 over 2.
But out of the 2 just get positive.
Divided by 2. No, well, that's genius. First of all, I'll move it to the other side. Yeah, okay. So now I can write tan theta equal 3 over 2. And let's see, this is thing we've done already since probably grade 10. What do we do now?
Oh no, you go inverse.
Correct. Okay, so what I'm going to write, okay, I'll change. Don't copy that yet, okay? I'm going to write theta equal tan inverse 3 over 2. And then I can put in the calculator, right? Except that I want you to get used to, and we taught that, instead of theta, yes, who was that? Okay? We say the reference angle is 3 over tan theta 3 over 2. And I'll explain why do we need that reference angle in a second. Okay? So that we can put in the calculator, and I'll need your help on this, guys. Let's just get the calculator. I'll pause here. So the answer is 56,31 degree. Okay? Now I need to figure out the thetas. Okay? So to do that, I'm really going to draw my favorite Cartesian plane. Okay? And I've got first quadrant, second quadrant, third quadrant, and fourth. Okay? I can maybe do also these things. Theta 180 minus theta, theta plus or minus 180, and 360 minus theta. Okay, so I already know that there's 2 solutions. This is just one solution. Okay? 56,31. What's the other solution? Or let's say, where does he live? This lives in the first quadrant. Where's the other solution?
Plus 180.
Plus 180. Because I've got a positive number here, then I can add 180. Tan is still positive here. So I'm going to do 56,31 plus 180. Okay? Right? Except, okay, let me just write down what the answer is. 236,31. Except that, and I didn't tell you, I need to find what we call the general solution. Okay? So I need to add something to these things. What do I need to add something? What do I need to add?
It's like K360 or something.
Right? 360K. Okay? K is any number, is an integer. Okay? Okay, 0, 1, 2, 3, minus 1. Hang on. Okay, and yeah, you're right, but just a second. So I need to add these 360Ks because if I'm going 360 degrees, I've got to where I point. And now, yes, Simon, what do you want to say?
180.
All right. So when it comes to tan, okay, we can always just add 180. Instead of adding 360, I can add just 180. Okay? If you notice that, how did I get to 236? I just added 180. Okay? So really, okay, I should write those two things together as theta equal 56,31 plus 180k. Okay? This is only true for tan. For sine and cosine, we're going to have two solutions and we'll just add 360 to each one of them. But these two solutions are just 180 plus the other. So final solution is this. I'll just pause here. Next one, a little bit more difficult, is cos theta plus 1 equal 3 sine squared. Now, before we had a sine and a cos, that's fine. We just divide by cos and we create the tan. Now, because I've got a square, I'm not going to just divide by cos. It's not going to work out. So anything you can think, I mean, I want to have turn this into an equation where I have just one trig function. Before I turn it to a tan. Okay, now I have a cos and a sine square. How can I get rid of one of them?
Sine squared underneath.
Correct. So what you've got to remember is that sine squared theta is 1 minus cosine squared theta, and cosine squared theta is 1 minus sine squared theta. These are very important relations that you're going to use to get rid of sine. I've got a cosine here, I'm happy with that, but I don't want the sine. I want to have one trig function. Then I can do the inverse. Okay? So I'm going to keep this one the same. In fact, yeah, keep that the same. And I'm going to write 3 times 1 minus cosine squared theta. Okay? And now I've got one equation with only cosine. Let's get it all to the one side. So, okay, I'll write it slowly. Cos theta plus 1 equals 3 minus, 3 cosine squared theta. Now we're going to move everything to one side. So we're going to have 3 cosine squared theta plus cosine theta minus 2 equal to 0. Can you see what I've done here? Okay, what am I going to do now? It's a trinomial, isn't it? It's a trinomial. Just instead of x, I've got cos. So you could use, the k method. You don't have to, but you could use the k method, okay? So you can say k equal to?
Cos theta.
Cos theta. And then with this substitution, we can write 3k squared plus k minus 2 equal to 0. And then we just solve it. How do we solve it? Do we trinomialize? Just use the calculator, okay? Just use the calculator. So don't worry, I will... so my answers, I can tell you what my answers are. It's if you factorize it, okay? Sometimes it's fun to factorize. Some people like that, okay? You'll factorize like this. But you could get just your answer from the calculator. You'll see that k equal 2 over 3 and k equal minus 1. So you've got two solutions. Yeah? You use the calculator, no problem. Now we got to convert back to cos. Okay? So either cosine theta is equal to 2 over 3 or cosine theta equal negative 1. Okay, now let's start with the easy one. When is cos equal to negative 1? Here, your trig function needs to kick in. Okay, and I know it's been a long time. Okay? Trig functions, not trig function, trig graphs is what I meant to say. Okay? A cos graph looks like this. It swings from 1 to minus 1 and back to 1. So what will be the answer? When is cosine theta equal minus 1? Which angle is that? 180. Isn't it? At 180, cos 180 is negative 1. So theta is going to be equal to 180. And I'm looking for the general solution, so I can always add 360k. Okay? So that's one kind of solution. Okay? We'll call it theta 1. Okay? A bit trickier is this one. Okay? So we're going to write reference angle, kind of running out of space. Okay, let me just pause and make some more. Now let's write it down here. We've got space here. Okay? So I'm writing it here. So solving this, reference angle equal cos minus 1 of 2 over 3. Okay, are we happy with that? Can you still see me? Okay, now the answer is, I'm not going to ask you, I'm just copying from these guys. Where am I? So the reference angle equal that, it's equal to 48,19. 48.19. That's what the calculator said. Okay? So now I've got two solutions. Okay? I'll stand here. Okay? The first, or we'll call it the second solution. That's the first solution. The first solution is going to be 48.19 plus 360k. Yeah? The second one, or the third one, where else is cosine positive? In which quadrant?
One is the first one.
At the fourth. Okay? So what I gotta do, I'm just checking that I've got it right. So it's gonna be 360 minus 48.19 plus 360k. Okay, so I took that 48, did 360 minus that one up here, and then I can keep on adding 360k. So I'm gonna get theta 3. Okay, I'll just see how much is that. If I can find myself again. So yeah, that's 311.89. 311.81 plus 360, there should be a k. Okay? So really you should, to make sure you get all the marks, so rewrite all these things. I'm being a bit lazy here. Rewrite all the final solutions. You need to have 3 types of general solution. I'm just checking that I've got it all right here. Chaps, the next question is quite a tricky one, and I'm going to introduce you to a trick. Okay? So I've got 7 squared sine squared plus sine cosine minus 6. Now, what would your guts telling you? What would you do? I mean, there's no point in converting that using 1 minus cosine squared because I'm still stuck. I've got sine and cos. It could be a trinomial. Yeah, but I've got sine and cosine. Sorry? No. In my mind, what I was thinking, I said, maybe I can take a sine as a common factor, and then I'll have 7 sine plus cosine, but then I'm stuck with that 6. Yeah. Yeah, but then I can't solve. To solve, I always have to have equals 0. So look, what they're telling us to do here, and you know, I probably wouldn't have picked if I didn't see it, is that we must use sine squared plus cosine squared equal 1. Okay? To make it a trinomial, because you are right, there is a trinomial here, I need to turn that into a sine and cosine. How can I take a number and turn it to sine cosine? Okay? Let's see. So I'm going to leave this like that. Okay. And instead of 6, I'm going to write 6 times sine squared theta plus cosine squared theta.
Which one?
Because what is that? It's just 1. Okay? Let me just pause here. So I know it looks very strange right now, but at least hopefully you all agree with me that I'm allowed to do this because this is just 1. Okay, now we're opening up. Okay, the question, why is this useful? Okay, 7 sine squared theta plus sine theta cosine theta minus 6 sine squared theta. I'm opening it now. Minus 6 cosine squared theta.
So I think you can take one factor now.
Okay? Getting it. So first of all, I've got 7 sine squared, 6 sine squared, so that becomes sine squared theta. This is the next term, sine theta cos theta, and this is the cos, minus 6 cos squared theta. Okay? Just have a look at that. Okay? Now, this sort of stuff we've come across way back in grade 10, but without the trig. Okay? So I'm going to I'll call it the K method, and then maybe it will look a bit more similar to something we've done. Okay? Let me just check that I've got it right. Yeah. Okay? So I'm going to do 2 substitutions. Okay? One for sine, one for cosine. Okay? Let's say sine theta equal x and cosine theta equal y. Let's just use this substitution. So what will I have? What is the first term? X squared plus xy minus
6y squared.
That's it. And stuff like that. If you look at your grade 10 textbook, we've done. These are trinomials. They're trinomials with 2 variables. Okay? And I'll just pause to make sure I got it right and then remember how to do that. So this is similar to something like this. Let's say x squared plus x minus 6. Okay? Let's do that one first. Let's do that one. Then maybe that will help us doing this. How do we factorize this? We all know how to factorize this. It's going to be x. What is that? Come on, guys, we know how to do it. Two numbers that multiply to minus 6 and add up to, that's it, my plus 3 minus 2, right? The same thing here, guys, the same here. The only difference is that we also have a y. So we're going to have our x's here, and we're going to have the y here. So y times y is y squared, and now I'm going to put in the numbers. Two numbers that multiply to minus 6 and add to 1, plus 3 minus 2. Can you see that? We've done that in grade 10, once upon a time. Okay? And unfortunately, the calculator can't help you then. Okay? So that should be equal to 0. Let me just pause and we'll make some more space. Very, very justified frowning action from Taylor. It should be minus 3, not minus 3. Eh? Yeah, absolutely. Okay? Let me just check that we're on the right track. Cos theta. No, we made a mistake. Hang on, there's something wrong here. So all good. We didn't make a mistake. Okay, well, I did, but Taylor found the mistake. So if I take this and I try and solve it, I'm going to get the reference angle equal tan minus 1 of what? This is what I wanted to do with you guys. Okay, I want to find out what the reference angle, tan minus 1 of?
3.
Good. Who's that? Ollie. Okay? So the idea is that if we have a negative number, when we try to find the reference angle, we always took the positive value. Why? Because the reference angle forever, ever lives in the first quadrant. And we know that everything is positive. Tan, they're all positive. So I'm always looking for the reference angle. That doesn't mean that it's a solution. From the reference angle, then I need to figure out what's the solution. So the reference angle comes up as... okay, so I'm not sure how much it was recorded. I'll try and recap quickly what we've done. Don't worry, guys. I know you're still on break. Okay? But we did the factorization. We found the relation between x and y. Or in other words, between sine and cosine. Okay? That gave us two equations. Okay? The first one I already solved. Tan theta equal minus 3. Well, I didn't solve it. Wrote it down. Okay? And then we tried to solve it using our reference angle. Remembering that we put the positive value, not the minus 3, the plus 3. That gives us the angle in the first quadrant. Okay? But because we know we're getting a negative answer, I really should be working in the second quadrant or the fourth. So I'm going to get the answer in tan. I can do it. I can guess just the one quadrant, the second quadrant, and add 180k. That's going to send me to the fourth quadrant, and then more and more and more and more. So that is one solution. You still have one more solution when we solve the equation 2, which is going to be tan theta equal 2. So you're going to do the same thing there. Okay, let's move on to the next. Okay, our next problem, I don't know if you can really see it. I'm going to write it down a little bit below. Sine alpha plus 10 equals sine alpha minus 30. Now, at first glance, it looks very easy. There's just sine. It's just sine. Okay, there's no cosine and no cosine square. But what is the problem here? Okay, until now we had sine x, cosine square x. It was always the same, what I would call argument. Here I've got alpha plus 10 and alpha minus 30. You understand? Okay, so I've got different things here. I haven't had it in the last questions. So what I'm going to do, I remember doing it once, not too much. We did a little bit last year. You got to decide on one of them to be the reference angle. Okay? And it could be really anyone. I'll just choose that. I would say this is my reference angle. Okay? So in other words, if sine this angle equal to sine of that angle, okay, that means, so I'll write down, I just want to write it down as that. Yeah. So I'm going to write down alpha plus, or let's put it this way, alpha plus 10 equal to the reference angle. You don't need to write that down, okay? This is just some kind of reminder. So really it tells you that alpha plus 10 is equal to alpha minus 30 plus what? Oh, should I write it? Yeah, plus 360k, right? Plus 360k. Okay? But there's one more solution. Okay, well, let's get that first of all. Let's just do that. Hang on, this is not going to help me, right? Yeah, okay, let's go on with that. Okay? So you understand why we did that? Alpha minus 30 plus 360k. Okay, we want to solve for alpha this thing. What happens now? How do we solve that? That's my first one. Take alpha to the other side. But what will happen then? Ooh. If I do minus alpha, I'm going to have 0, right? And then I move the 10 to the other side, so I'm going to have 0 equal minus 20 plus 360k. Minus 40. So I moved the alpha to this side. It killed it. Move the 10 to this side. Can minus 40 plus 360k ever be equal to 0? Never, because this is plus 360 plus 720 minus 360. It's never going to be right. In other words, there's no solution here. Okay? Okay? Luckily for us, there is another option. This one's the first solution. Okay? To get that first solution, we just said, naively said, well, that must be equal to that. That kind of makes sense. It's like drop the base we did with exponents. If sine an angle equal to sine another angle, that means these angles are the same. But if you think about it, these angles can never really be the same. Alpha plus 10 can never be alpha minus 30. So luckily we have another solution, which we didn't mention. Alpha plus 10 could be equal to what? Not alpha minus 30, but something with it. Okay, let's think about it. Sine is positive in which quadrant? First and second. So here we were just looking at the first quadrant. But there could be an answer in the second quadrant. So what should I do here to get that? No, plus 180. 180 minus. Okay, it's not plus 90. It's 180 minus. So if I want to go from first quadrant to second quadrant, I need to do 180 minus the angle. So these angles, either these angles are the same, which it didn't work out, so no solution, or this angle equal 180 minus that. I know you guys are a bit lost. If I have sine 30 equal sine x, or let's put it like this. Sine 30, or sine x equals sine 30. Okay, what's the obvious solution? There's one obvious solution. X equals 30. That's one obvious solution. But there's another solution. X can also be equal to 180 minus 30, which is 150. You know that if you plug in 150, sine 150 is the same as sine 30, right? So you see you've got the second solution we need to find. And that's the one that's going to work here. Okay? Obviously I need to still add 360k. And then let's just open it up. So alpha plus 10 equal 180 minus alpha plus 30 plus 360k. Now I can move the alpha to the other side, but check, it's minus alpha here. So when I move it to the other side, I'm going to have 2 alpha. And then it's going to give us the solution. Then I've got 180 plus 30 is 210, minus 10 is 200, plus 360k. And finally I write alpha equal 100 plus 180k. Let me just check that I've got it right first of all. 100 plus 180.
You say 180 because you divided by 2.
Correct. If I divide by 2, I must divide that 360 as well. It's nothing special. It's like anyone else. Okay? Right. That's the solution. Let's pause here. Guys, our last question of the day is that cosine alpha plus 30 equals sine 2 alpha. Now, I know we've learned the double angles, and next lesson we will use them. But you shouldn't be tempted, you might be tempted to use double angle, but it's going to lead you to a wrong path. Okay? I've got cosine an angle equals sine another angle. Now, the problem is that I don't have the same trig function. Before I had the same trig, cos was, or sine was equal to sine. But I know of a way to turn this thing to a cos. If I insist on having a cos, I want to have the same cos so I can compare the angle. What can I write here? What must I write here? I can't write 2 alpha. What can I? Good, cofunction. 90 minus 2 alpha.
Cos to a sine.
Sine to a cos. In this case, or cos to a sine, but it's the same. Now, again, I'm going to call that the reference angle. And that means that I have 2 solutions. The first is alpha plus 30 must be equal to 90 minus 2 alpha plus 360k. That's your first solution. Before I go over that, let's write down the second solution. alpha plus 30 can also be equal to what? Now, check. This is a positive value. So I'm asking myself, when is the cosine positive? Okay, 1 is just in the first quadrant, so these two are equal. Where? In the 4. So instead of writing 90 minus 2 alpha, I need to do something with that. What do I do with that? Okay, it's not equal to that, it's going to be equal to, say again, Lottie?
360 minus.
Fantastic. And I still need to add 360k. Okay? Now, a little bit of algebra, which I'm just going to quickly do it without thinking too much. Okay? So I'm going to have 3 alpha equal 60 plus 360k. Okay? Divided by, I'm hoping I'm not making mistakes here. Divided by 3, I'm going to have alpha equal 20 plus 120k. That's one solution. And the second solution is going to be, this is plus 3 alpha, so it's going to be minus, whoops, that's plus, so that's, sorry, that's 2 alpha, right? So I'm going to have minus alpha, 360 minus 90, how much is that? 270. 270 minus 3 is 240 plus 360k, and then I'm going to have to time everything by minus 1, so alpha equal minus 240. Now, strictly speaking, I need to do minus 360k, but because k can be a negative number, I can always just write it plus.
So how did you get to 3 alpha?
Okay, first of all, let me just see that I got it right, and then I'll answer your question. This is it. Cheerios.